So this video is for Integrated 3, Chapter 5, D-Day number 1, problems 5A through D, dealing with the normal curve. So I added normal curve on, and I'm just going to use it just to help us understand the situation here. So for this problem, we're dealing with temperatures for the month of September. There's an average of 78 degrees with a standard deviation of 6. And we want to figure out for this, how many days in September. So how many days, not probability or percent, but how many days would you expect to be between 84 and 90? Okay, so let me just draw this in. So for this, we are going to be at 78 degrees for our mean. Okay, that's going to be our mean. And then when I go out 1 standard deviation, 2, 3, these are the positive z-scores, -1, -2, -3. Each time I am taking the 6 degrees and adding or subtracting. So in this situation, this would be, I'm adding 6, so 84 degrees. I'm adding 6, so 90 degrees. I'm adding 6 to, so 96 degrees. Going the other direction, subtracting 6, 72 degrees. Subtracting 6, 66 degrees. Subtracting 6, 60 degrees. And we want to be between 84 and 90 degrees. So first thing we're going to do is we're going to figure out the percent that are going to be within this area. So we are going to do normal CDF. So we are going to be doing the normal CDF if we're using the graphing calculators. And we're going to be doing the normal CDF. The lower bound is going to be 84 degrees. The upper bound is going to be 90 degrees. The mean is 78 degrees, and the standard deviation is 6 degrees. And when we put that into our calculator, we end up getting a 0.1359, which is about 13.59%. Now, I added on over here what we had done with our, when we had found all these probabilities using the standard normal curve in the table. And you see that where I'm talking is right here that we had already seen was actually that amount. We had figured that out back when, but we did that without the calculator. Right here, we can use the calculator, okay? Now, that means it's 13.59%. We want to know how many days in September. So 30 days in September times 0.1359, because there's 13.59% of the days. And that's going to give us about a 4.07. So about 4 days. About 4 days that are going to be within that range. Okay, so let's take a look at the next problem. Okay, so for this one, Mr. Templin promised that if we score at least 50% on the test, we will pass. Okay, now that's not 50% of the normal curve, it's on a particular test scoring 50% or more. Now, in this situation, they say that sadly, the mean was 46% with a standard deviation of 4%. If the scores were normally distributed, what percent of the class passed? Okay, so let me just kind of fill in the information. So the mean was 46%. And the standard deviation is 4. So 50 would have a z-score of a +1. Z-score of a +2 would be 54. Z-score of a +3 would be 58. Going the other direction, I'm taking 4 off, that would be 42. I'm taking 4 off, that would be 38. 8. I'm taking 4 off. That would be 34%. Okay. Now we want to have 50 or higher. So 50 or higher is going to be this. This is what I'm going to be looking for. So on my calculator, I'm going to do the normal CDF. The lower bound is going to be 50. The upper bound is infinity, but we can't put infinity in, so we're going to go 10 to the 99. Our mean is, 46, and our standard deviation is 4. So we put that into our calculator, and we end up getting a 0.15, let's say 87. So that would be 15.87%. Now, again, these were nice Z-scores. So if I look down here for this one, let me get rid of that. We were looking at here on. So actually, wait, hold on for a second. Yeah, one on. So basically, if I was looking at 0.5, which is this half here, that is going to be 0.5. And here, let me kind of shade, sorry, make it a little more clearer. So if I'm looking here, this whole thing here is 0.5. Okay. Then I add on this 0.3413. Okay. So I basically either can do 1 minus 0.5 minus 0.3413. And when I put that into my calculator, 1 minus 0.5 minus 0.3413, second, sorry, 0.5 minus 0.3413, I get the same answer I got up there, 0.1587. Another way to have done this is to add up this, and this. So 0.1359 plus 0.0215 plus 0.0013 gave me that same answer. Okay, so we actually could have also found it from this, but again, you can use your calculator. Let me just get rid of this. Okay, so again, for this problem, it ended up being 15.87%. On the next one, okay, Math Club sells their famous chocolate chip cookies with a mean of 10.5 ounces and a standard deviation of 0.75. Okay, so for this, 10.5 is our mean. Okay, and we're adding this, get this set up here. We're going to be adding and subtracting 0.75. Okay, so 10.5 plus 0.75 gives me 11.25. Add 0.75 again, I get a 12. Add it again, I get a 12.75. Going the other direction, if I subtract 0.75, I get a 9.75. I subtract 0.75, I get a 9. I subtract 0.7, I subtract 0.75, and I end up getting an 8.25. Okay, so for this one, it says, what percent of the Math Club's cookies are below 8 ounces? So if I want it below 8 ounces, okay, let's just say 8 ounces is going to be somewhere over here beyond this, right? So I'm looking for somewhere over here. I'm not quite sure what, but this is going to be 8. So if I'm doing it just on a straight curve here, that's our mean, which is, put the mean in here, 10.5. Okay, we want it to be 8. We want it to be below 8. So we're actually looking for this section right here. I'm thinking it's going to be a very small probability because it's outside of 3 standard deviations. So we are going to, though, put in normal CDF. We're going to go to negative infinity. So that lower bound is going to be a negative 10 to the 99. Upper is going to be 8. Mean is 10.5 and standard deviation is 0.75. Okay, I put this in my calculator and I end up getting, I think I'm going to get something in scientific notation. Okay, so it gave me 4.2912, let's say, but it has an E with a -4. That is scientific notation. So that really means, let me write it in red. That really means I'm going to move my decimal. So it really means times 10 to the -4th, which means I'm going to move my decimal 4 places. So I'm going to have 0.0004 291, let's say. Okay, so that's not even a percent, because if I move my decimal 2 places, I'm going to get 0.04291%. That's a very low percent. Okay. And when you're looking here at this, you see that I'm outside of that 3 standard deviations, which is a very small percentage. Okay. This one here, my Pi Pod has an average playtime of 9.4 hours with a standard deviation of 1.5 hours. Okay, so the average is 9.5 hours. The standard deviation is 1.5. What is the playtime in the 92nd percentile? Okay, so if I'm looking at this, so this is 0.95 with 1.5 hours. Okay, so let me just, I'm drawing this out because some of us aren't really thinking about where we are on the normal curve when we're drawing our things out. So I'm going to be filling it out again so we understand where we are. So I'm adding 1.5 onto 9.5 and I get an 11. I add 1.5 again, I get a 12.5. I add 1.5 again, I get a 14. Now going the other direction, 9.5 minus 1.5 gives me an 8. Subtract 1.5 again, I get a 6.5. Subtract 1.5 again, and I get a 5. Let me make that 6 look like a 6. Okay. Now we want to be in the 92nd percentile. Okay. So basically, if this is my mean, which is 9.5, I want to figure out where this needs to be so that 92% is beneath this. Okay, so this right here needs to be 0.92. That's what I'm looking at. So if I'm just kind of thinking about over here, going from here to here is 50% or 0.5. Okay. If I add on this, I'm going to be at 84.13. If I add on this, so my 84.13 plus 13.59, I'm at 97% all the way up to here. Okay, so I should be somewhere in between here, somewhere in between 1 and 2. Okay, but we don't even need to think about that. I just want you to understand that we should be higher than 9.5 as our answer, and it should be on the right side of the mean. And let's just say I put X here. This is not going to be a normal CDF. I know the area or the percent. So this is going to be an inverse norm. So I'm going to do inverse norm, and it's going to ask me for area. It's 0.92. Don't put it in as a 92. Most area that you can ever have for these is 1. That would be 100%. And then our mean is a 9.5 and our standard deviation was 1.5. And I hopefully am going to be getting something in between 11 and 12.5. So let me put in my calculator. And 0.92, 9.5, 1.5. I end up with an 11.61, let's say, as our answer. And that is within this range. Okay, so that's the amount of hours that would put us in the 92nd percentile. Now, if you stay tuned to this video, I'm going to pause it. I am going to show us how to do these on Desmos for those of us who are interested. So this is going to show how to do the normal distribution and inverse norm on the Desmos. So if you go to functions and you go to distributions, normal distributions, okay. Oops, hold on, let me try it one more time. Go to normal distribution, okay. It's going to start off with a standard normal curve. If I hit this, it'll show a mean of 0 and a standard deviation of 1. Okay, and then this would be cumulative, showing the area from negative infinity to infinity. Now, ours is not a standard normal curve, okay? For us, we have a mean of 78 and a standard deviation of 6. So I am going to put in a mean of 78 and a standard deviation of 6. So now when I look at this, it will show it adjusted, okay? And we'll see that this is up at 78. Okay, so now I want to go for this, not from negative infinity to infinity, but from 84 to 90. So I'll put 84 to 90. And then it will show me and then give me the answer, okay, which you see over here was a 13.59, okay. Then we had times it by 30, and you can times it by 30 on this. The next problem we had was this one here, where we had a, just a little more over here. Get back and put it more on the screen. Okay, so this one we had a mean of 46 and a standard deviation of 4. So a mean of 46 and a standard deviation of 4. And let me get rid of that for a second and let me redo that. Okay, so we don't want those values. So you see right now it's going to show it from negative infinity to infinity. For this one, we want it from 50 to infinity. So I can put 50 in here and it's going to show me the answer, which is a 15.87, which is what we got here. Now, the next one, we had a mean of 10.5 and a standard deviation of 0.75, so a mean of 10.5 and a standard deviation of 0.75. And let me just get rid of that for a second. Okay, and let's clear that. Okay, so that's what the picture looks like. For us, we wanted it to be less than 8 ounces. So we wanted it from negative infinity to 8. And you see 0.0004. And here, if we see it in the picture, move this. Okay. You can see that it's really off of this. You can see it right there. It's really, really teeny, teeny, tiny. Okay. Now, the next one is an inverse norm. Now, I'm going to get my normal curve to fit this, which is 99.5 hours for the mean and 1.5 for the standard deviation. Okay, so hold on. Sorry, I deleted it. Didn't mean to delete it. Get it back. Okay, so normal distribution. Okay, so we want it to be 9.5 hours and 1.5 standard deviation. If I show cumulative one, okay, there you go. It's showing that to us. We want the inverse norm, and we want the inverse norm for 92%. So I put in the normal distribution here. Okay, I'm going to need this. So I'm just going to copy this. And I'm going to come here to inverse norm or inverse CDF. I'm going to put that in there because that's the normal distribution with the mean and the standard deviation I want, comma, the area I want, which was 0.92. And then you see I get this value. Okay. Now, if I was to go from -infinity up to, I'm going to copy this to this value, you see that that is 92%. So that matches. And that's the end of this video.